Our brains are master storytellers. They weave a seamless narrative of the world around us. But this reality is a meticulously crafted illusion. Our perception is a subjective interpretation, generated by our brains. Confined within our skulls, our brains rely on electrical impulses from our senses. From these, our brains construct our subjective reality. Our reality is a simulation, an internal model of sensory input. Imagine yourself walking through a bustling city park. Sunlight warms your skin, the scent of freshly cut grass fills your nostrils, and the laughter of children playing rings in your ears. Specialized receptors in your eyes, ears, nose, skin, and tongue convert sensory information into electrical signals. These signals travel through nerve fibers to your brain, where they are decoded and interpreted. This process brings the richness and complexity of our sensory experiences to life. Our brains are not passive receivers of information. They are proactive, constantly generating predictions about the world based on our past experiences and incoming sensory data. This predictive processing model suggests that our brains are constantly trying to anticipate what will happen next, using these predictions to fill in the gaps and create a seamless experience of reality. Imagine you are driving down a familiar road. You've driven this route countless times before, and your brain has developed a detailed internal model of the road's twists and turns, landmarks, and potential hazards. As you drive, your brain is constantly predicting what you should see, hear, and feel based on this internal model. When your predictions match the incoming sensory information, your experience of reality is smooth and effortless. But what happens when our predictions are wrong? What happens when the brain encounters something unexpected or surprising? In these instances, the brain generates an error signal, a neural alarm bell that indicates a mismatch between its predictions and reality. These error signals are crucial for learning and adapting to new situations. They force the brain to update its internal models, refining its predictions to better match the ever-changing world around us. This constant interplay between prediction and error correction is essential for our ability to learn, make sense of the world, and navigate our surroundings effectively. Our brains are masters of deception, often filling in the gaps in our sensory perception without us even realizing it. This phenomenon, known as perceptual filling in, highlights the constructive nature of our perception, demonstrating how our brains actively shape and interpret the sensory information they receive. One of the most striking examples of perceptual filling in is our blind spot. We all have a blind spot in each eye, a small area on the retina where the optic nerve exits the eye, devoid of any photoreceptor cells. You would think that this would create a noticeable hole in our vision, yet we are completely unaware of it. This is because our brains, receiving visual information from the surrounding area, seamlessly fill in the missing information based on the context of the scene. Another fascinating example is the phenomenon of motion blindness, a rare neurological condition in which individuals are unable to perceive motion despite having normal vision. People with motion blindness experience the world as a series of static snapshots, with moving objects appearing to jump from one location to another. This condition highlights the brain's role in constructing our perception of motion, demonstrating that movement is not simply a matter of our eyes tracking a moving object, but a complex process of neural interpretation and prediction. Section 5. Time warps. How our brain manipulates temporal flow. Time, the relentless river that carries us from one moment to the next, is a fundamental aspect of our existence. But what if I told you that our experience of time is not a faithful representation of reality but rather a malleable construct subject to the whims and caprices of our brains? Our brains have the remarkable ability to manipulate our perception of time, stretching it out, compressing it, or even making it appear to stand still. Think about a time when you were completely engrossed in an activity you enjoy, whether it's playing a musical instrument, having a stimulating conversation, or losing yourself in a good book. In those moments of flow, time seems to melt away. Hours can pass in what feels like minutes. This phenomenon, known as temporal compression, occurs when our brains are so engaged in the present moment that they filter out extraneous sensory information, effectively slowing down our perception of time. Conversely, our brains can also stretch out time, making it seem to crawl by, especially during periods of boredom, fear, or intense stress. This temporal dilation occurs because our brains, in an attempt to cope with the overwhelming nature of these experiences, increase their rate of information processing, leading to a subjective slowing down of time. Section 6. The illusion of choice free will under the microscope. The concept of free will, the belief that we control our thoughts and actions, is deeply ingrained in us. But what if free will is an illusion, a comforting story we tell ourselves? Neuroscience challenges this view, suggesting our choices may be predetermined by unconscious brain activity. Benjamin Libet's experiments in the 1980s showed brain activity occurring before conscious decisions. This raises questions about whether our choices are truly our own. Section 7. Predetermined decisions, unveiling the brain's hidden machinery. Libet's findings, while controversial, ignited a firestorm of debate about the nature of free will and the implications for our understanding of moral responsibility. If our decisions are indeed predetermined by unconscious brain processes, does this mean that we are nothing more than biological automata, slaves to the deterministic whims of our neural circuitry? While the idea of our choices being predetermined may seem disconcerting, it's important to remember that our brains are incredibly complex organs, shaped by a lifetime of experiences, memories, values, and aspirations. The neural activity that precedes our conscious decisions is not random, but rather a culmination of all these factors, reflecting our unique personal history and shaping our actions in the present moment. Furthermore, the brain is not an isolated entity operating in a vacuum. It is constantly interacting with the environment, receiving a constant stream of sensory information that influences its activity. This dynamic interplay between our brains and the environment makes it difficult, if not impossible, to predict our actions with absolute certainty, even if we could fully map out the neural activity that precedes our conscious decisions. Section 8. The implications, rethinking reality, identity, and free will. The idea that our perception of reality is a construct of the brain, shaped by our senses, experiences, and expectations, has profound implications for how we understand ourselves and our place in the universe. If our reality is not an objective reflection of the world but rather a subjective interpretation, then what does this mean for our sense of self, our relationships with others, and our understanding of truth? The realization that our brains are constantly filling in the gaps, distorting time, and even making decisions before we are consciously aware of them can be both humbling and liberating. It humbles us by reminding us that our perception of reality is inherently limited, filtered through the lens of our own subjective experiences. But it is also liberating because it frees us from the illusion of certainty, opening up the possibility for greater understanding, empathy, and compassion. If we accept that everyone's reality is shaped by their own unique set of experiences and perspectives, then we can begin to bridge the gap between our subjective worlds, fostering greater understanding and connection. Section 9. Embracing the unknown, the future of understanding consciousness. The exploration of consciousness, perception, and free will is a journey into the uncharted territories of the human mind. As we continue to develop new technologies and methods for studying the brain, we are sure to uncover even more surprising and awe-inspiring insights into the nature of our own existence. The more we learn about the brain, the more we realize how much we still don't know. But this is not a reason to despair. It is a call to embrace the unknown, to approach the mysteries of consciousness with a sense of wonder and curiosity. For in the exploration of these profound questions, we may just discover the key to unlocking the full potential of the human mind.